Quantum electrodynamics. Quantum electrodynamics, or quantum electromagnetism, is a theory in physics that explains how light and matter interact at the quantum level. It is one of the most precise and successful theories in science, providing accurate predictions about the behavior of particles like electrons and photons, the fundamental particles of light. Despite its complexity, we will break down the key concepts of quantum electrodynamics in layman's terms to make it more accessible. At its foundation, quantum electrodynamics describes how charged particles, such as electrons, interact with electromagnetic fields. Electrons carry a negative charge, and they interact with photons, which are particles of light. Traditionally, light was understood as a wave, and electrons were treated as distinct particles. However, in quantum physics, light can behave both as a wave and as a particle, and the same principle applies to electrons. This dual behavior is known as wave-particle duality, a fundamental concept in quantum mechanics. Quantum electrodynamics operates within the framework of quantum mechanics, a branch of physics that deals with the behavior of particles on the smallest scales, such as atoms and subatomic particles. Unlike classical physics, which describes large objects like planets or cars with predictable motions, quantum mechanics describes a world of uncertainty and probabilities. In quantum physics, particles don't follow fixed paths. Instead, their behavior is described in terms of the probability of being in various states. One of the key ideas in quantum electrodynamics is that interactions between particles occur through the exchange of force-carrying particles called photons. Imagine two electrons coming close to one another. Both electrons carry the same negative charge, and like the repulsion between two magnets with similar poles, the electrons will repel each other. According to quantum electrodynamics, this repulsion occurs because the electrons are exchanging virtual photons. These are not real, visible photons like those that make up light, but temporary particles that only exist during the interaction, pushing the electrons apart. This concept of force carriers is crucial to quantum electrodynamics. In the case of the